All right, so now that we know what scientific notation is, we know how to write numbers in scientific notation and transform back and forth between scientific notation and standard notation, let's use this scientific notation to our advantage. And it will be really helpful when answering questions kind of like these. So the speed of light is approximately 1.86 times 10 to the fifth miles per second. That's really fast. And my question might be, how far is 1 light year? A light year is the distance traveled by light in 1 year. And a really helpful piece of information is that 1 year is 3.154 times 10 to the 7 seconds. Or the sun, very heavy, we learned before it is 1.989 times 10 to the 30th kilograms, very heavy, is obviously more massive than Jupiter, the largest planet in our system, which is 1.898 times 10 to the 27th kilograms. But, I mean, how much bigger is the sun? Is it like 10 times bigger, 1,000,000 times bigger, 1,000,000,000,000 times bigger? I don't know. How can we compare these two numbers? Or, for instance, we know that 1 atom of sodium weighs approximately 3.818 times 10 to the negative 27th grams. Well, then how many atoms are there in a single gram? So it's going to be all about how do we multiply and divide these numbers written in scientific notation. So let's answer our first question, how far is 1 light year? And in so doing, we will find a general way to multiply numbers that are in scientific notation. So if you told me that light travels this many miles every second, and this is how many seconds there are in a light year, well, if you ask me how far light travels in 1 year, I would take this speed, 1.86 times 10 to the fifth miles per second, and I would multiply it by however many seconds, by this number. So I think if you want to know how far 1 light year is, I'm going to take 1.86 times 10 to the fifth, and I'm going to multiply this by the number of seconds in a year, which was 3.154 times 10 to the seventh. All right, so all we got to do is multiply these. And it's actually not so tough. Note to self, what we've got here is multiplication throughout. I might even say this as 1.86 times 10 to the fifth times 3.154 times 10 to the seventh. So what I'm going to do is I'm going to do a little bit of rearranging because I think it would be much easier to write it as such. 1.86 times, I'm going to use an x for multiplication so we don't get it mixed up with decimals, times 3.154, right? Just using the commutative property of multiplication times 10 to the fifth times 10 to the seventh. That's all I did is I just rearranged the terms that we were multiplying. Well, not surprisingly, I think 10 to the fifth times 10 to the seventh, I hope you guys know what that is. That is 10 to the 12th power. Now, I don't expect you to be able to do this in your head. 1.86 times 3.154, but it's approximately 5.86644. Let's rewrite that 5, make it a little cleaner. And so you have the distance that light would travel in 1 year in miles. In 1 year, light should travel 5.86644 times 10 to the 12th miles. All we did was we multiplied these two numbers in scientific notation. And in general, what I do whenever I multiply two numbers in scientific notation is I first multiply the 10 to the something powers. I mean, why not? Nice and easy, same base, we can use our properties of exponents, no big deal. We ended up with 10 to the 12th. And then I take whatever these constants are in front, each between 1 and 10, multiply them together, and, well, see what we end up with. Now, note to self, in this case, it was nice that we ended up with a number between 1 and 10, but if we were to multiply these two and get a number not between 1 and 10, we'd have to be a little careful and make sure that we then transform this into scientific notation. And we'll see that in one of the examples we're going to look at right now. So we've got 4 examples. I'm going to walk you through 2 of them, and then I'll have you try 2 on your own. So in this case, we're just multiplying the numbers 5.2 times 10 to the 7th, multiplied by 3 times 10 to the 8th. Again, all multiplication, we can use the commutative property to multiply in whatever order we would like. Let's go ahead and multiply our 10s raised to some powers. I think 10 to the 7th multiplied by 10 to the 8th will give us 10 to the 15th power, just using properties of exponents. What are we going to be multiplying that by? We're going to be multiplying that by whatever 5.2 times 3 is, which is 15.6. So 15.6 times 10 to the 15th. Okay, now we got to be careful because this number, as it stands, is not actually written in scientific notation, right? 15.6 is not between 1 and 10. So I hope we know that we're eventually going to have to transform this into 1.56 times 10 to the something power. Now we got to be really careful and make sure that we accurately change this exponent to reflect the change that we put in this constant right here. Okay, what I'm going to do is I'm going to take a moment and actually take this 15.6 and I'm going to write that kind of in scientific notation. I'm going to write this as 1.56 times 10 to the first. So what does that mean? It means that our original line there was actually 1.56 times 10 to the first times 10 to the 15th. And from here, I hope you can see, aha, this is 10 to the 16th power. Our final result will be 1.56 times 10 to the 16th. But it's very confusing often to figure out how do I go from this not scientific notation to this scientific notation, right? Should this be 10 to the 16th? Should it be 10 to the 14th? How does the exponent change when we change this number? What I like to do is kind of take an intermediate step and sort of write this in scientific notation. I mean, that was a pretty easy step right there, and then it really helps clarify what to do moving forward. All right, let's do one more together, and then I'll have you do some on your own. Okay, so same idea as before. Let's go ahead and concentrate first on our 10s raised to powers. 10 to the 12th multiplied by 10 to the negative 4th. I hope we know that's going to equal 10 to the 8th power. And 6 times 2, well, that's 12. So we've got 12 times 10 to the 8th, not in scientific notation. I'm going to go ahead and I'm going to take this 12, and I'm going to write it as 1.2 times 10 to the 1st. I hope that's no problem. Times 10 to the 8th. Aha. That tells me that actually if I wanted to write this in standard notation, excuse me, scientific notation, 1.2 times 10 to the 9th power. Okay. So I hope we're getting the hang of it. Let's have you try these two examples on your own. All right, go for it. Pause the video, try them out, and when you're done, play it, and we'll see how it went. All right, for, I guess all three of these are called B. Oops. So for the second question B, I think we're going to end up with, let's see, 3.4 times 2 is 6.8, and 10 to the negative 7th times 10 to the negative 8th is going to give us 10 to the negative 15th power, and we're done. That's it. 6.8 times 10 to the negative 15th power. There you go. Moving on, our last question B, if you will. I can immediately see that we're going to have some issues here because 7.3 times 3 is 21.9, which is definitely not in standard form. 21.9 times 10 to the 13th. All right, so let's write this 21.9 as 2.19 times 10 to the 1st times 10 to the 13th. Bringing that down. Okay, so we've got 2.19 times 10 to the 14th. Booyah! And we are done. Okay, so that's kind of how you multiply numbers that are in scientific notation. Not so bad. Occasionally, you're going to have to be careful of your product not originally being in scientific notation. Okay, not so bad. All right, moving on. Dividing numbers in scientific notation. Here's the question. How much bigger is the sun than Jupiter? I mean, is it like 10 times bigger? Is it 1,000,000 times bigger? Is it, almost the same size? I mean, I have no idea. Let's find out. So if you ask me how much bigger is the sun than Jupiter, you know what I do? I take the mass of the sun, I divide it by the mass of Jupiter, see what we get. Right? If my quotient is 2, then I'd say, okay, the sun is twice as big as Jupiter. If my quotient was 1,000,000, I'd say, okay, the sun is 1,000,000 times bigger than Jupiter. So let's find out. So let's go ahead and divide these. So we've got 1.989 times 10 to the 30th, and we're going to divide that by 1.898. Well, that's coincidental that it kind of almost has the same number there, times 10 to the 27th. All right. And what I'm going to say is here, the strategy that I use for dividing numbers in scientific notation is very similar to the strategy that I use for multiplying them. I kind of do a little divide and conquer, right? So we've got a lot of multiplication going on here. So what I'm going to do is I'm going to first actually just rewrite this fraction as such. Hope you can see kind of what's happening here. All right. So my claim is that these two expressions right here and right here are exactly the same, right? This is kind of just, if you were to multiply these two fractions together, multiply the numerators and multiply the denominators, you get the exact same thing. And we are really doing a dividing and conquering. And so, for instance, I think, right, what we can do is we can handle these 10s raised to some powers kind of on their own, right? That's pretty easy. This is just a property of exponents we can use, and we end up with what? 10 to the 3rd power. So 10 to the 3rd power. And then we will deal with these constants kind of on their own. 1.989 divided by 1.898. Can I do this off the top of my head? No. I mean, it's going to be just a little bit bigger than 1, barely bigger than 1. it's around 1.05. So 1.05 we'll say multiplied by 10 to the third. Okay, and you can convert this into standard form. This is just a little bit over 1,000. I think this is 1,050 to be honest. But well, what does this mean? It means that the sun is about 1,000 times bigger than Jupiter. And oftentimes when you do this kind of a calculation, you'll get a number here and that's great. But here is the real information, right? 10 to the third. It means that the sun is about 10 to the third times as big as Jupiter, right? About 1,000 times. If this had been 10 to the seventh, that would have been a huge deal. I mean, that's so much bigger than 10 to the third. 10 to the seventh is, what, 10 million? So if this had been 1.05 times 10 to the seventh, we would have said, wow, the sun is about 10 million times bigger than Jupiter. Yes, of course, this number is important as well, but even if this was an 8, that only makes so much of a difference. This power on the 10 is the real big indicator. When we're talking about these really big and really small numbers, right, some quantities are going to be thousands, millions, billions, trillion times bigger than the other. So that's just a really helpful way to capture that information in which scientific notation really uncovers the relationship. So the sun is about 1,000 times bigger than Jupiter. Who knew? Okay, but that kind of uncovers the general strategy for dividing numbers in scientific notation. So let's do it. All right, so in our first example, 9 times 10 to the 17th divided by 1.5 times 10 to the 8th, both in scientific notation. Let's do a little dividing and conquering. 10 to the 7th, 10 to the 17th divided by 10 to the 8th will yield us, let's see, 10 to the 9th power, 10 to the 9th power. 9 divided by 1.5, well, that's actually a nice number. That's 6. 6 times 10 to the 9th, that is that's our answer in standard in scientific notation. Everything worked out very nicely. That's pretty awesome. All right, making moves. We'll do one more together, and you can do 2 on your own. All right. So we got 3 times 10 to the 8th divided by 8 times 10 to the negative 5th. 10 to the 8th divided by 10 to the negative 5th. I hope we know that that is going to be 10 to the 13th power. What are we going to be multiplying that? We're going to be multiplying that by whatever 3 divided by 8 is, and I think 3 divided by 8 is 0.375. Uh-oh. We are left with something that is not in scientific notation. Remember, this number has to be between 1 and 10 for this to be scientific notation. Okay, got to be really careful. Here is my strategy. We know that eventually our final answer in scientific notation will be 3.75 multiplied by 10 to the something power. Probably either 14 or 15. 14 or 12, right? We're moving the decimal place by a little bit. We're probably going to change this exponent by 1, but I don't know. Is it bigger or smaller? Let's use that same little strategy that I showed you before. Let's take an intermediate step to just write this number by itself in scientific notation. I think this is 3.75 times 10 to the negative first power, right? Remember, all we had to do is take this decimal and move it 1 space to the right, making this number bigger, in order to make this into 3.75, a number between 1 and 10. And so I hope we can agree that this is how we'd write this number in scientific notation. Let's tag on that 10 to the 13th from before, and I hope now it becomes very clear. Aha! Our final answer will be 3.75 times 10 to the 12th power. So we know how to divide numbers in scientific notation. We might come up with a tricky scenario like this. I just want to make sure we're able to handle it. All right. Are there a bunch more B's? look at these letters. C, then B, then D, then B. Who knows what's going on? Okay. Why don't you try D and B on your own? Pause the video, try them out, then play the video, and see how it went. Okay, looking at question D, if you will, I hope this was no problem. We end up with 2 times 10 to the 12th power. Just be careful, be careful, be careful. Don't be tempted and do 16 divided by 4. Careful, careful, careful. That's why I put it there. 2 times 10 to the 12th power. Okay, last one. A lot of negative exponents. I immediately see we're going to have some issues here. Right? 3 divided by 6. 3 over 6 is 0.5 times, let's see, in purple, 10 to the negative 18th. All right, well, let's see what we got. 0.5, also known as 5 times 10 to the negative 1, multiplied by our trusty 10 to the negative 18th. I hope that this sheds light on the fact that our final answer will be 5 times 10 to the negative 19th in scientific notation. Okay, so now we know how to multiply and divide numbers in scientific notation. So, hope this was helpful, and hope you enjoyed.